Hi everyone, welcome back to Huffman channel. I am Chandan Biswas and this is a new series which I have presented for you. In this series, we are going to discuss some concepts and understand the inner mechanism of those concepts. Based on those concepts, we are going to do a question which has been asked previously in any of the competitive exams. If you like the series, do comment below on what topic would you like to have the next video on. I would be glad to go for your requests. So let's jump right in today's video. We are going to discuss about Hoffmann Bromamide Degradation. This is a very important concept which is repeatedly asked in JEE Advanced. Not on the superficial level but also on the intricate mechanism which goes on inside this reaction. The reaction of Hoffmann Bromamide degradation is basically a formation of primary amines from primary amides. The basic reaction of Hoffmann Bromamide degradation looks like this. As we can see, the amide here is always 1 degree. 1 degree as in the nitrogen should be connected to single carbon itself. In place of bromine, and in alkali medium, especially KOH or NaOH, this leads to the removal of this carbonyl group, and this NH2 and R combines together to give us a good yield of 1 degree amine. This is a beautiful way of producing 1 degree amine with maximum yield. Now these reagent, which is bromine and KOH, can also be written as KOBr in some questions. Instead of KOBr, it can also be written as OBr minus. OBr minus is called a hypobromite ion. So basically we are converting an amide to an amine containing 1 carbon less. So as you can see that number of carbons will be 1 less than the original amide. That is why the name is degradation. In some cases we can also call it a step down reaction. Step down reaction means when number of carbons become 1 less. Now let's have a look at the mechanism and the intricate things which go inside the mechanism steps. In the mechanism of this process, we have to start with the amide which we were talking about. This is our amide which is 1 degree. The first thing which comes into picture is the base OH minus which we were thinking about. As we saw here that KOH gives us the OH minus ion, and this OH minus will be looking for some acidic hydrogen. The best acidic hydrogen is available on this nitrogen because when it loses its hydrogen, this one is going to get a negative charge which is stabilized by resonance of this CO group. Hence, these hydrogens become very acidic in such cases. So what happens is that this OH minus grabs this hydrogen and the bond pair comes down to nitrogen. As we can see now, this is formed as a result of the reaction. Now there is bromine molecule, which is a non-polar one. Now bromine, when coming close to this one, gets slightly induced, and this one gets a positive sign and this one gets a negative sign. As a result, this nitrogen will try to bond with this bromine, and this bromine as a result will try to move out because of the negative charge. So this attack will take place and Br minus gets released, leading to formation of this molecule. Now this molecule, as you can see, we have an amide group and a bromine. This is the bromamide which we are talking about. Now as we see that bromamide is not the end of the product. It is undergoing attack again because it still has one more acidic hydrogen which will be abstracted by another OH molecule which is coming from KOH. So another OH minus comes into picture and it will try to grab this hydrogen again, pushing the lone pair towards the nitrogen, which eventually gives us. But now the next problem is that Br minus in general is a very good leaving group. So Br minus can leave, but if it does, N will still have to be get stabilized by resonance. So what happens is that if this lone pair moves here and this one moves here, we see that no new structure is formed, no new compound will be formed. This will only give us the resonance hybrid of this. So this step is really important. The next step which is going to happen. The next step is the rate determining step, where this alkyl group completely shifts over this nitrogen, pushing out this bromine. This is a single step reaction and the most important and the slowest step. We call it rate determining step or the slowest step. Now this entire R is going to migrate over this nitrogen, pushing out the bromine group, which is a good leaving group, and this lone pair is going to come over here. So this entire thing happens in a single step. It is also known as concerted step. Now please remember, if R is chiral, the migration is going to leave no chance to flip it so that its configuration remains unchanged. That much of coordination is required for this, and this is the slowest step. Eventually, this gives us a compound which is this resultant compound is named as alkyl isocyanate. This is isocyanate and not isocyanide. Fun fact, methyl isocyanate is a gas which was the major cause of death in Bhopal Gas Tragedy, which is exactly a derivative of this compound. Read more about Bhopal Gas Tragedy in the links in the description. Now let's move on to the further steps inside the reaction. Now this alkyl isocyanate is going to get attacked by a water molecule. Carbon being very much electrophilic, it tends to get attracted with the lone pair of oxygen of water, and this N will attract the H, eventually giving us the compound. This compound is called hydroxamic acid. Eventually, this hydroxamic acid loses its carbon dioxide, and after loss of CO2, we are going to get RNH2, which is the final product of this reaction, which is a primary amine. So let's summarize this entire process into quick and important features. The first feature is that it produces primary amines. The next feature is that it is a step down reaction. The third feature was formation of alkyl isocyanate was the most difficult step and the slowest step involved in the entire mechanism of this reaction. And the fourth one is that the overall number of moles of KOH required in this case would be 4. Now if you look at closely, we have used 1 mole of OH over here, 1 mole of OH over here, but there are 2 moles of KOH consumed more when this CO2 gets released. 2 moles of KOH are consumed again in order to produce K2CO3. So keeping that in mind, the overall balanced equation is written as this. And the next feature would be, if R is chiral, then the migration happens in single step. The configuration will be retained in the amine produced. Please note that there is no carbocation formation in this case. Now let's have a look at a problem which has been asked in JEE Advanced 2006. So this is a passage based on Hoffmann Bromamide Degradation in JEE Advanced 2006. Now let's have a look. So what we have in this question is that we are seeing a conversion of an amide to an amine with 1 carbon less by the action of alkaline hydrohalide or hypohalide, whatever you can call it, is known as Hoffmann Bromamide Degradation. We see that it is a 1 degree amide which gets converted into bromamide, which eventually undergoes loss of hydrogen and undergoes rearrangement like this. The migration of this toluene group to this nitrogen and movement of this lone pair towards here, giving us alkyl isocyanate. Eventually it gets attacked with water to give us this compound, and finally a loss of carbon dioxide to give us primary amine. The questions related to this mechanism is given as here. How can the reconversion of 1 to 2 be brought about? Let's have a look at the reaction of 1 to 2. As we saw previously, that 1 to 2 becomes possible by loss of 1 hydrogen, which means that 1 OH minus is reacted along with the reaction of bromine. OH minus and bromine are the required conditions to create this bromamide. So the correct answer will be bromine along with KOH, which means D is the correct choice. In the second question, we see that what is the rate determining step in Hoffmann Bromamide Degradation? As we discussed above, formation of methyl isocyanate is the slowest and the rate determining step. So the slowest step must be conversion of 3 to 4. This is alkyl isocyanate, and therefore formation of 4 is the slowest step for this reaction. Hence, D must be the correct choice. And the next question in the comprehension asks us what are the constituent amines formed when the mixture of 1 and 2 undergoes Hoffmann Bromamide degradation. As I told you that whenever the alkyl group migrates over N, there is no change in its configuration. And it is not possible for both the alkyl groups to swap places because we are using a mixture of these two compounds here. It is not possible for any alkyl group to migrate to other nitrogen of other molecule. So therefore, this must migrate to its own nitrogen itself, and this phenyl group should migrate to this nitrogen. Eventually, it should give us the product of this from this reaction and this from this reaction. So these should be our desired products. These two choices are given in option B. Hence, this concludes our discussion today about Hoffmann Bromamide degradation. I hope you enjoyed learning in details and the specifics of the mechanism. If you have more suggestions on what topic would you like to understand next, drop down your suggestions in the comment box. And also do not forget to subscribe to Huffman channel and hit a thumbs up on the video. Tap the bell icon for the latest updates. I'll see you in the next one. Bye bye.